without further ado, Tom Morris from Veritas Genetics is here to talk to us about the Arvados platform, and I'm really excited to hear more about this, as I think many of us on our respective campuses have heard about this platform and be interested to know more about it. So without further ado, I'll turn it over to you, Tom, and you'll be able to share your screen and then really take over from that point.
Cool, thank you very much. Let me just get this shared for you. Oh, actually, it looks like that's my entire desktop. Let's try that again.
That looks like it. Yeah, that's
cool.
Perfect. Thanks, Tom.
Okay, so as I mentioned, I'm the Director of Product Management here at Veritas. I actually came into Veritas through acquisition of a company called Cureverse, which is was the original developers of the Arvados platform. So Arvados is infrastructure software designed specifically for managing and processing big and distributed data. It was originally targeted at genomics data, but it has been used for imaging, radio astronomy, all kinds of other applications as well. It's designed for storage and compute at scale. It's used in a number of large production scenarios, and it's designed to be able to reliably support those types of installations. It's 100% open source. There's a project-specific website at arvados.org in addition to our corporate websites. It's a modern architecture, which I'll go into in a little bit more detail. It's built from the ground up for federation, which is something that we think is very important for these types of applications. And one of the things about big data is that it tends to not be very feasible to be shuffling the data around. Although I know you guys have a very fancy system for being able to do that at high performance. In general, it's much better to move the computation to the data rather than the other way around. And federated architectures allow for doing that easily and reliably. It supports all three native cloud platforms, as well as on-premise HPC clusters, and can be used in a combination of those. We have customers that have migrated from one to the other, or use both. As well as using multiple cloud vendors. There's workflow portability across all of those platforms and a uniform API across all of those platforms. So everything at the layer above Arvados is something that hides all of the differences underneath. As I mentioned, it was designed to deal with genomic data originally. It came out of the Church Lab at Harvard Medical School. From quite a few years ago when George, who's a kind of forward thinker, was seeing the cost of sequencing coming down and the explosion of genomic data on the horizon. And it was really designed to be able to handle that scale, as well as to be able to provide some of the scientific attributes that are important, like provenance and reproducibility and things like that. Excuse me. There are three main components to Arvados. There's a storage layer, which we call Keep. It's a content address store that scales up to petabytes of data. There's a workflow manager called Crunch, which is designed to be able to reliably and reproducibly run complex workflows and be able to provide the provenance to trace back to where all of the outputs came from. There's a query engine called Lightning, which is a combination of query engine and compression technology that compresses human genomes, or any genome actually, down to a very compact representation that's quick to query and is also efficient for doing machine learning. And it's a format that's amenable to machine learning. Everything in the system is built on a common set of APIs that are the same APIs that we offer for extending and integrating the system. So there are no special private internal APIs or anything like that. Those APIs are offered through a variety of SDKs supporting Python, Go, Java, Ruby, and R. And there's also a set of command line utilities that can be used for shell scripts. And then on the right, you see the web interface that we have as well. That's the current generation. We've got a next generation web interface that's in beta now, which I will show you a shot of later. The whole system is designed to be easily extensible, and the APIs can be used either, as I mentioned, to extend it or to integrate it. So one of the things that, for instance, Veritas does, so Veritas' main business is sequencing for, so direct-to-consumer genetic testing. And so as such, we have very large-scale sequencing operations, and it's important for us to be able to track customer orders as they go through the system. The APIs can be used to integrate with our various operational dashboards, to have back-end workflow processes kicked off when a new order comes in, and deliver the data when it's done, and so on. The core definition language for describing workflows is called the Common Workflow Language. This is an industry standard language that came out of one of the open source conferences about 4 or 5 years ago, and is something that CureVerse, the Arvados engineering team, has been involved with helping standardize and both write the specification as well as contribute to the reference implementation that's used as a core of a lot of the other implementations. As you can see from the list of participating organizations, it spans both commercial organizations, including some of our competitors, as well as academic organizations and research institutions. So it's got very broad support, and the ecosystem is continuing to grow. One of the things that I think is really powerful about that is it provides for a community where you can share workflow definitions, share tool wrappers. So just saw something pop up here. Is someone chatting for me? Oh, no, okay.
Oh, sorry, that's me lagging.
Okay. Tool wrappers, as well as just knowledge, so to be able to help each other out. So I think that's one of the really powerful things about CWL. And that's the workflow language that all of the system runs on. So to go through the components I was talking about before in a little bit more detail, the storage layer is called Keep. Everything in the system is content addressed, which means that all of the data is run through a cryptographic hash, which produces a small, unique value that can be used to address it. All the addressing in the system is done using that. So one of the things that provides is automatic deduplication. So if you have 2 copies of any, you can never have 2 copies of any piece of data. If someone tries to create a new copy, the system will recognize that if it's already got that and just use that copy. It also means that creating copies is a very efficient process because it's just a matter of moving pointers and incrementing counters. That content addressing is also used to support some of the provenance features that I'll talk about in a minute. on the next slide. It can be backed by either cloud object storage or a traditional file system on HPC cluster, including cluster file systems. So it can either be just a single file system or a cluster file system. Scales up to petabytes, and there's kind of two levels of abstractions here. One is a hierarchy of projects and subprojects, which can be nested arbitrarily deeply, and within those, and those are the basic unit for sharing of data. So all data is private by default, but you can share a project and its children with individuals or groups of individuals, and they can be granted either read access, read-write access, or manage access, which allows them to share on with other people. So very fine-grained permission system there, which is useful for managing access to data. And then the other basic abstraction is a collection, which is basically a virtual folder that contains a bunch of files. So the workflow manager, Crunch, is built for reproducibility. It uses the content addresses that are maintained by the storage layer, as well as the content addresses that are maintained by Docker to provide for very strong provenance. So all of the software is containerized and all jobs run inside Docker. By looking at the content hashes for those containers and the content hashes for the inputs, you can tell easily the exact constituents of any output that you've got. So you're able to trace from the outputs all the way back to the various levels of input. The other thing you can do is use that to take a look at, to do smart job reuse. So if you're on step 37 of a 40-step process and the system fails either due to a bug in your workflow or a glitch in the cluster or a glitch in the cloud, rather than restarting from the beginning or having to manually slice up your workflow and run it in pieces, the system automatically knows that it can start at the failed step and skip all of the previous steps, because by looking at the content hashes of the inputs and the content hashes of the Docker containers and seeing that they're the same as the previous run, it knows that as long as the computation is deterministic, it can reuse the outputs without having to recompute that. So that's very useful in a development environment where you want to be able to iterate very quickly and fix a bug and restart and fix the next bug and keep going. It's also very useful for cost savings in a production environment where some minor glitch caused a failure, and you had a transient error with a particular computer or something like that, and you can just restart from where you left off and save all that money rather than recomputing things. The other thing that this does is for cloud installations, it will dynamically scale up and down the compute capacity so that when you need, if you have a workflow that's parallelized across all of your 23 chromosomes, you can spin up 23 computers. If it's parallelized across 100 samples, you can spin up 100 computers and basically get as much compute capacity as you need. One of the nice things about cloud pricing is that it's basically linear, so you can get lots of little computers, a few big computers, lots of big computers, and pay pretty much the same amount to get things done much more quickly. I talked a little bit about provenance. So this is kind of a graphical view of what a provenance graph looks like. So you can see The rectangles here are data collections, and the ovals are compute processes. So you can see how you can trace from any output back through the computation that produced it and back to the original inputs, including not only your sample data, but any reference data that was used, as well as the actual software that was used. So I talked a little bit about federation and moving the workflow to the data. There's a bunch of reasons for doing that. In the genomic space, because the data is big, that's one good reason, but it's also information which is privacy sensitive. So there's often transporter data laws that prevent you from moving things across national boundaries, or just organizational issues where you can't move things across organizational boundaries. So one of the things that Arvados allows you to do is to be able to push workflows out to remote clusters, and if you have the appropriate privileges, be able to run the computation there and then repatriate some summary data that you then could do meta-analysis on. And by being able to partition things like that, you're able to fit within a variety of different scenarios that where it wouldn't be feasible to be able to have to centralize all of the data. Some of the recent features that just wanted to highlight that were added for people that are familiar with earlier incarnations of Arvados, added support for storage tiers, so you can roll things off to cool and cold storage tiers to save money. Support for spot instances, which are much cheaper pricing. Distributed workflows, so in addition to being able to have a single workflow that you push to a remote cluster, you could have a distributed workflow that did some of its work remotely and then some of its work locally, and be able to stitch all of that together. And all of that is supported by federated identity support across all the clusters. So this allows you to be able to easily manage your sharing controls and what access you want to grant people. Having a federated identity doesn't give you any additional rights per se, but it does give you a common identity across all of the clusters. So you can use that for setting up your various roles and sharing setups. Support for versioning of collections, so that if you have different metadata associated with them or change the contents, you can go back and look at previous versions and see what was there. The new version of the Arvados web interface, which we call Workbench, is in beta, and also Python 3 support. So this is actually what the Workbench 2 beta looks like. You can, if you're familiar with Google Drive at all, you see it's kind of similar to that. It's a much more modern implementation. So the original Workbench is a Ruby on Rails app. This is a single page React app, and was designed from the ground up with a cohesive user experience, and it's much more performant and responsive. Excuse me. So we think it's something that will be very attractive to customers. So just in terms of the experience that Veritas has, and the engineering team here has been working on this since 2006, have clusters across a number of different continents with more coming online, petabytes of data under installation, and used for very large scale. One of the things I mentioned is that Veritas uses it for all of its production work. There are a number of large companies that have multiple clusters spread across multiple continents, use it to support their day-to-day operations. And this is kind of a recapitulation of the stuff that I talked about before. I think in the scientific environment, the fact that it's open source and provides such strong support for provenance and reproducibility are some of the really key features here. And with that, hopefully I'm within my time budget and I will take questions.
Excellent, thanks, Tom. I've got a question maybe to lead things off. Well, first of all, thank you very much. That was a great overview. I'm interested in this notion of federation, and you know, it certainly addresses some of the issues that I would say a number of domains experience, not just genomics. In the case of the federation implementation you have, what capability would you have of actually sort of moving the data in the event that that was desired? Like if you agreed to federate with some other institution, would there be the opportunity to actually move those data to one of the other sites within that federated system?
Yeah, absolutely. So in the distributed workflow case, if the data is remote and you have access to it, it'll actually be fetched from the remote system. And so the current implementation is that that's fetched during processing and then cached locally. But you could certainly imagine scenarios where you do more sophisticated things. We've kind of resisted going crazy with pre-staging data, doing fancy optimization until we kind of see how customers are using this in earnest. Some of these features are relatively recently added to the system. So, you know, generally you would want to run your workflow where the data is positioned, but in some cases, like reference data, you probably want multiple copies of it. So you want that, you know, scattered everywhere. And one of the things that the system knows is because the workflows have all of the information, they're completely self-contained in terms of what scripts are being run, what reference data is being used. When you move a workflow from place to place, you can actually, the system knows how to copy all of the reference data with it. So it'll do that for you automatically.
Okay. And that copying is being done securely, or what are the ways in which those data are moved? Say I have a local instantiation of the software. What sort of method are those data moved from one instantiation to the next?
Yeah, so everything's done over SSL links, so it's encrypted in flight. And the permission system requires you to have read access to the source and write access to the destination. So that's one of the things that by having a federated identity, the remote system could grant you write access to a particular project hierarchy, and you could put your stuff there. But without that, you're not going to be able to write anything there.
Gotcha. And have you found, are there many people using this federated component of the system, just dealing with that federated identity side? I'm just curious because this is something at universities we often run into, and NSF has done a lot to try to help us, you know, by promoting things like in common and so forth. But do you run into issues with federating across the identity management sphere? So
most of the federation setups that we have now are owned by a single organization. So the federation is used to deal with geographic diversity as opposed to organizational diversity.
Right.
Don't have a ton of experience with that. The other thing I guess I should say in this front is that there's a bunch of standards work going on in the GA4GH, which is the Genomic Alliance the Global Alliance for Genomics and Health, that is looking closely at federated identity issues as well. So we're tracking that work very closely to be able to fit in with that. And they have concepts of research passports that can be used for helping to support data access committees' decisions on whether or not access should be granted and things like that. So there's a lot of kind of policy machinery in addition to the technical machinery that's needed for these things.
Yeah, excellent. Thanks.
I had a question in a different direction. You said at the beginning that the platform was being used kind of outside of life sciences, but clearly your origins are life sciences and all the examples that you gave were life sciences. There's always a tension between the desire to serve everyone and the desire to do one thing well. I'm wondering if you could comment on how well the platform has generalized, but also kind of the snags that you've run up against as people have attempted to use it kind of outside of its originally intended domain.
So the examples I'm most familiar with are some of the image processing and both 2D and 3D image processing. And in those cases, I think they have kind of similar application profiles. So it works without really any issues. Some of the more exotic examples I'm not as familiar with, so I don't really know. I guess people probably kind of self-select. So if they try the system and it doesn't really work for them, then they don't push it too much.
Makes sense, thanks.
Other questions for Tom? We have time.
Well, I have a question. So in your system, are you using any Hadoop?
No, it doesn't use Hadoop or MapReduce style computation currently. So the most of the genomics tools are designed to run standalone. Often they're multi-threaded, but there is some movement to do Spark-based versions of some of the tooling, and we're tracking that. But it's a little bit kind of old school in terms of that. And the Hadoop style the MapReduce style of computation doesn't apply as readily to this.
Okay, thank you.
Other questions, jump in. Otherwise, I'm going to ask one about the analysis interface. Some of the layout actually looked a bit Jupyter-like. Have you had any interest in people actually using this environment to support, say, Jupyter Notebook-like interfaces for developing notebooks and other shareable products?
Yeah, there has been a bunch of interest in that, and some people have done some work on that. I have not looked at it recently to see. It's an area that we're interested in doing tighter integration with. Kind of on a similar vein, Workbench 2 has much better support for pluggable viewers for different data types and stuff, which also helps so that you can kind of wire up different viewers for different data types in the system and be able to use those easily.
And sort of thinking about your business, do you get pulled in cases where people are using this for data that might be considered protected by HIPAA? Say, do you work under a BAA, a business associates agreement, or have you not found that necessary at this stage?
So we don't offer this as a SaaS offering. So the kind of deployment model is typically we would install it in a customer's cloud environment or support them installing it on their local HPC cluster. So in that case, they would need a BAA with their cloud vendor, which they offer. And we will also work with them to, if they want to get, if they're doing drug development and need, higher levels of certification and stuff. Again, that doesn't apply directly to us, but we would support them in that because those typically have a bunch of training and procedural and other things. So we can, Arvados will not prevent them from doing that, and we can check all the boxes. But from kind of a relationship role, we just support them and provide them with the documentation and consulting and stuff like that.